Let's talk about negative exponents. I'm going to write this down on the top. And I'm going to start our story of negative exponents by first beginning with an example that you've seen before. Let's start with 3 to the power 2. I'm actually going to use color-coded exponents. So I'm going to do 3 to the power 2 in orange and 3 to the power 2 in green. So orange as the numerator and green as the denominator. Now, that's equal to 3 times 3 on top and 3 times 3 on the bottom. And we know that is, we can just cancel out the 3's on the top and the bottom to get a result of about, that should be 1. So, now I'm going to show you this same result using a different process. Now follow me really carefully here. I'm still color coding the exponents. So I have 3 to the power 2 over 3 to the power 2 in orange in the numerator and green in the denominator. And I know that is equal to 3 to the power 2 minus 2. Notice how I'm subtracting the green from the orange because I'm just subtracting the bottom 2 from the top 2. That gives us 3 to the power 2 minus 2, which is 3 to the power 0, because 2 minus 2 is 0. And we know that that's equal to 1, because anything to the power 0 is always equal to 1. Now, watch carefully. I'm actually going to go in opposite order here. I'm going to retrace our steps. 1 is equal to 3 to the power 0. We know this already. And we already know that's equal to 3 to the power 2 minus 2. I'm going in opposite order. Now watch really carefully what I do here. I'm going to write that this is equal to 3 to the power of, I'm going to write this in blue, 3 to the power 2 plus minus 2. Watch really carefully. It's a plus, and in the green, I'm going to write a minus 2. That's because 2 minus 2 and 2 plus minus 2 are the same thing. That gives me 3 to the power 2 times 3 to the power minus 2, because we know from the product rule that I can, when I multiply two exponents with the same base, I'm simply adding them together. I'm just going to go the opposite order here. That gives me 3 to the power 2 over 3 to the power 2, and that middle left column, the middle left part, is equal to this bottom right thing. I'm going to rewrite this result that I squared in lavender. 3 to the power 2 over 3 to the power 2 is equal to 3 to the power of 2 times 3 to the power of minus 2. This negative exponent just came out. I wonder what this means. Let's dig in a little deeper. Looking at the result that I got a little bit more closely, I know that the left side of the equal sign is also equal to the following. That's 3 to the power 2 times 1 over 3 to the power 2. Look really carefully at where I put my green and orange exponents. That's equal to the right side, which is the same. That's 3 to the power 2 times 3 to the power negative 2, as I had on the top. Notice here that the 3 to the power 2 is the same on both sides, but there's one thing that looks a little different. The 1 over 3 to the power 2, it looks a little different from the 3 to the power negative 2. It turns out that because they're both multiplied by the same number to get equal to each other, they should be the exact same. So I'm going to rewrite that. 1 over 3 to the power 2 is also equal to 3 to the power negative 2. You get this result by dividing by 3 to the power 2 on both sides. Now, this gives me a good idea of what a negative exponent is. So I'm going to write that for all non-zero x to the power of negative n is always equal to 1 over x to the power of n. As we see here, 1 over 3 to the power 2 is the same thing as 3 to the power negative 2. The reason why 0 does not work for x is because you cannot divide by 0 as well. So this is important, so I start it and I put a circle around it as well. Looking at this example problem, this is another example of the product rule. So I'm going to circle the negative 1 and the 2 and color code just like how I did before. That whole thing is equal to 3 to the power negative 1 plus 2. The reason why is because it's the same base, so I can simply add the exponents together, even if it's a negative number. I know that negative 1 plus 2 is equal to 1, so that result is equal to 3 to the power of 1, which, as we know, is 3 multiplied by itself, which is just 3. So I'm going to put that in brown. 3 multiplied by itself is just 3. I'm going to write that at the very top as well, just to make sure that we understand what's going on and that I'm writing my answer. Finally, let's check our work. We know that that result is the same thing as 1 over 3 to the power of 1 times 3 to the power of 2. I'm going to make sure I write that 1 at the bottom as well. That is equal to 3 times 3 to the power of 2 over 3 to the power of 1, which is equal to 3 times 3 over 3. And then I know that I can cancel out the 3 on the top and the bottom to get just 3, as I got last time as well. So check their work, looks pretty good. Now let's look at another example you might see. This is 5 to the power of 2 times 3 to the power of negative 3. Well, I can rewrite this as this whole thing is equal to 5 to the power of 2 times 1 over 3 to the power of 3. Because that's what we know about negative exponents. That's reciprocal with a positive exponent on the bottom. So that is equal to 5 to the power of 2 over 3 to the power of 3, which doesn't leave us very many options. We're actually done here because we cannot combine these bases because the bases are not the same. So that is equal to 25 over 27. Once again, the bases here are not the same, so there's not much more I can do here. Some of you might be thinking, well, I can use the quotient rule here, can I? Well, that's not quite it. Let me show you exactly why by showing you something that is wrong. This is not equal to 15 to the power of negative 1, which some people might say is 1 over 15 to the power of 1, which is 1 over 15. The reason why is because the bases are not the same. Once again, the bases are not the same. The 5 and the 3 are not the same, so we cannot combine them, and we certainly cannot add the exponents like we normally do. That concludes our examples. Let's go over some vocabulary before finishing up. When you take the negative exponent of any non-zero number, then you are finding the reciprocal with the positive exponent. This is really important. We learned about negative exponents and reciprocals today. And finally, let's review some key terms. So we talked about the fact that this can be used to simplify expressions. When bases are the same, we can simply treat negative exponents like we've been treating the other exponents so far. That's equal to 5 to the power of 3 plus negative 5, which is 5 to the power of negative 2, which is 1 over 5 to the power of 2, which is 1 over 25. Pretty straightforward stuff. Now when bases are not the same, this is really important. We can't do the exact same thing. We cannot use the product rule here. So this whole thing is simply equal to 3 to the power of 3 times 1 over 5 to the power of 2, which is 3 to the power of 3 over 5 to the power of 2. I'm not combining the bases here. And that's equal to about 27 over 25. Nice job. As always, make sure to reach out with any questions you have. We'll continue this tomorrow. For now, best of luck. Thanks for watching. Make sure to like, comment, and subscribe. See you tomorrow. I'm always joy, though it's not my dog, but so walking. Yeah, it wants to be my peace. This song, I'm the no limit, so I'm to know where my mind is. Oh.